Okay. Sorry about that. There have been a couple of technical problems, like my internet suddenly dying the second I've started the stream. Quite annoying. Hey everyone, Eyal Amir from Modalics here. And this is a continuation of these dev sessions that Or Lubjaniker, my partner, and I have been doing these last couple of days, working on a new music software or music composition product. There's going to be a lot of coding, a lot of analyzing, and there's going to be a lot of C++ work. This is our attempt to be a bit more upfront and sharing about things we're doing. Hopefully, there's going to be some educational value in this. I'm doing something that's I think is quite unique. It's quite interesting. It also means that because it's unique, there's always a process of discovery here. So Or and I are kind of defining what it is we're doing as we go along. And so this is what we're going to do. I'm going to be streaming this on a bunch of different networks. Just so you know, this is being streamed on YouTube, Facebook, Twitch, LinkedIn, Twitter, X, etc. So if you write something in the comment, for example, I'm going to, you see this comment here from David Frick, who saw that I was starting the stream and stopping it. That was because my home internet died 5 seconds after I started the stream. Very weird. But hopefully this one will be okay. I'm going to be here for a little while, doing coding, kind of breaking down this mammoth project that we decided to take on. Like you're going to see a lot of me diving into very deep implementation details, but I will also try to be educational and explain, analyze. So feel free to, just like David, post questions in the comments. I will try to put them on the screen and kind of communicate this, even if you're watching this on another network or something. I will try to make this clear. So we have just to recap things that are happening. We're working on the software that's a little bit like it's a music composition software or plugin. And the idea is that this is going to be something that will help you work with kind of algorithmic composition. So there's a set of rules that you will be able to specify and kind of create big and different pieces of music that will be kind of expressed with those rules. And the way that it's structured internally, which is what I think makes it so interesting and so difficult to write, is that this code is structured a little bit like a programming language. So the idea is that there's some elements of this that are kind of like functions, scopes, variables, things that you have in programming languages. But this one is interesting because, first of all, it's more like a functional programming language. So it is quite an interesting model to think about things. It's different from procedural programming or object-oriented programming, stuff like that. Now, to make it more interesting, the language where I'm implementing this software, maybe I guess I should also say, maybe obvious, but the program itself will not be a programming language. It's going to have a UI. The model of what you would see is a little bit like a visual programming language, but there's not going to be any text typing on the user side. There is, however, going to be a lot of text typing on my side, and to make it interesting, the implementation that you will see is not written in the same language as the result. It's going to be written in C++, which is not a functional language. It's going to, the paradigm of the implementation is going to be very different from the model of the UI. So there's going to be a lot of like mental translations that I would have to do between one to the other. yeah, and it's already like there's already a little bit written here. There's quite a lot of bugs, so it's I'm still building big parts of the basic implementation. Yeah, so let me just switch modes here. Let's see how easy did I make this on myself. Let's say I switch to this. This is gonna work. No, I knew it was gonna fail. I had this app that tries to control the stream. I knew it was not gonna work. Okay, yeah, just this. Great. So you'll see this is my very rudimentary app here. The app is not going to look like this. This is my dev mockup, which is just going to be used to implement features. And while I'm doing this, Orel Bianiker, my partner in Modalics, he's designing this. We're gonna look at his designs a little later. He makes much better designs than I ever could. So he's thinking about all this from a higher level perspective, and I'm just implementing low level features. Like you see, there's a list of things here. There's 3 blocks here. One is just a number, literal int, or A. The other one is called B, the other, which is a music. It's a music sequence that I pre-wrote into this. And the other one is a transpose, and you can wire one into the other. Like so, transpose takes music from this and a number from this to know how much it has to transpose. And I can also add something like a repeat, duplicates, and then it will take the music from the output of transpose and get a number of times to do this. Can I change this number? No, I need to be able to change this number in a better way. Yeah, okay, this is probably a task for later. Yeah, so then you can repeat this. You can say, okay, well, we'll repeat this thing, more than once, right? And get much longer music, and you can create like music with a lot of variety in this once they start adding the different blocks and different aspects. So and you will over time will be able to use higher and higher level blocks. And notice that unlike I don't know how many people here have watched something like I've looked at stuff like modular synthesizers or stuff like that. A lot of the stuff you'll see in those is blocks that are stateful. But these particular blocks are not stateful. They're functional. They're pure functions. So you can reuse them. And yeah, so Jesse's asking, what is MusicLang UI? Yeah, so MusicLang UI is what you're seeing here. It's basically my let's call it my prototype project to oopsie, let's move this. I want to move myself over here. That's good. So it's about MusicLang is a language that processes music for composition. The language, this is just a very initial draft that I have of features in the language. The program is not going to look like this, but it's a visual programming language that's meant to take to work with music. Like when you think about the building blocks of this programming language of sorts, it's not MIDI notes. It's themes, motives, phrases, song parts, stuff like that. So it's quite a higher level elements. Yeah, so it's a language meant for people who want to do algorithmic composition. And it's going to be when I'm starting to I'll start to add some more higher level blocks. You'll see that this language this language conceptually can create very powerful music from a few blocks. Like you'll be able to create devices like this. It's like a chain of things where you pass some MIDI phrase into it, and it outputs a full chunk of evolving music. So it's going to be interesting. And there's another question here from Jesse. Do you use DSP? Yeah, a lot of the code we write has a lot of DSP. We write audio plugins. If you know the plugins that we made in Modalics or plugins that I made in the past for other companies, like Waves, Polyverse, Dead Mouse, all this stuff. It's all DSP based plugins. So, and this is no different. This is a language that one of the features about the implementation of this language is that it's able to run in the audio thread, which is, by the way, also a difficult problem because the the audio thread has all kinds of limitations to run at real time, but this language can do this. Like it can, you can move a MIDI controller and evaluate a bunch of different functions that will create all these different, dynamic arrays and stuff, and no memory will be allocated. At least this is the hope. It has not been battle tested just yet to see that every situation is covered, but this is really the goal of this. Like it's a real time. It's a language that runs in real time, but the essence of it is not DSP. This is not a language to do DSP. It's not going to do audio effects. It's not going to do, it's just not a language for effects. It's not a language for synthesizers. It's nothing like this. This language does not, you will not see, a float array in here. Like you will not see, an audio buffer or something, or a MIDI buffer. What you will see is things that are more high level. That's really the design goal, because I want to put this in the hands of people who are composers. At the end of the day, people who want to kind of experiment with different ideas to create complicated music. This is also something that's going to work very well with AI, because AI can generate some of these blocks for you, including some more complicated blocks. For example, you could tell an AI, give me something that over 5 minutes evolves in this way and has these variations, but I want you to work with my theme, right? You can give it a theme, and what it's going to output is not some incomprehensible piece of MIDI, but it's going to give you a list of blocks that you, hopefully as a user of the program, you know how to use, and you can modify them until you find your own style. So there's quite a lot. We're still in a very low level element of developing this, but hopefully in the next few days, the higher level aspects will be will start to materialize, and there's going to be use cases that I've tested, in my like proof of concept, experiments, that this can do quite a lot. Like with a few simple blocks, you can create very interesting music with this, which if you had wrote those procedurally, and with the for loops over the MIDI notes and stuff like that, this would have been difficult. It's very difficult to do. It's a problem that usually DAWs solve with all kinds of MIDI clips and stuff like that. So there's another question here. So Jesse says, sorry for the questions and disturbance. First of all, there's no disturbance. This stream is a lot about the interaction and being able to having your questions and trying to have a dialogue about what it is we're doing, because I could just turn off the stream and keep programming, but this is more fun. This is more engaging for me as well. So what type of language are for audio effects and synthesizer? Yeah, so most stuff like that are implemented in C++, which is, by the way, the exact same thing that I'm doing, because our code is the same. We have the same code base for MIDI processing, audio processing. Anything we do in Modalics is all in C++, because it has to run very fast. It has to run at real time. It has to run in a way where it's doesn't call the system. So we can't usually use languages like Python or JavaScript. We have to use something like what I'm using now, which is just C++. Or you can use something like Rust, or whatever. There are all kinds of interesting attempts to write higher level languages. There is something now called C major that only handles the DSP. Like it's not unlike C++, where in C++ you can write your not just the DSP part, but in C++ you can also write the UI or file management or preset management. Like you can write basically your whole program in C++. But there are languages now that don't cover all this stuff, but they do cover the DSP side very well, like C major, like Faust. That's another one. That's another language that lets you describe signal processing. And these are actually really good languages because they compile to very efficient C++ or assembly code. So with something like C major, for example, if you write you write some chain of processing, you can be guaranteed that there's not going to be anything there in the compiled binary that's going to be not real-time safe or something. So that's safe, but you will have to find other languages to write your program. So if you write code in something like C major or Faust, you might need to switch to JavaScript to write your UI, or some kind of language that can help you complete the program. With C++, which is what most of my, or pretty much all of my streams will be on, I don't need to switch languages. I write the UI, I switch to another file, I write the DSP, I switch to another file, I write some mid-level communication thing. Okay, so hopefully that answered that question. I will say again, I'm streaming this on a bunch of different networks. Like you might be seeing this on my LinkedIn, like Jesse, or on YouTube, like David. But I'm streaming this also on Facebook, on Twitch, Twitter, X. So you feel free to write me a comment, and I will try to post the comment on screen so that everyone from the other domains could see this. So what I'm doing like specifically now is, what I'm going to do is I am going to, so the question is, you write in CLion, EAP, C++ code. Yes, CLion is my IDE. I am on the latest EAP, which is like a beta. So, and there are some bugs in this beta, but hopefully not bugs that will ruin the stream, just annoying little things. That's my IDE from pretty much everything. I love the stuff that JetBrains are doing in general. I'm not sponsored by them, but I do like their other products as well. Like they have, a set of IDEs that are similar but for different purposes. So I like CLion, I like DataGrip. I like WebStorm. It's another one that I like. PyCharm, like they make really good stuff for different languages. So yeah, I definitely like CLion. Okay, so let's see what's going on. So what I'm doing just right now, I'm working on a very specific problem that we found in my implementation during the previous stream. Let me recap, because this is quite complicated to explain how the things are structured here. The model for this, and to check the model, I'm actually going to switch away from the MusicLang UI to a very simple console app program that I'm using for testing. This is using the same library, the same language library, but calling it from a console app. It's just easier sometimes to test things from a console app. It's a little bit more predictable than something like a UI. So what usually you'll see me do is I'll implement things in this, very simple. This is like a main function that calls my test function. I'm calling a function here because sometimes I'm kind of doing A/B testing between different functions or something. So I like that there's a function call here where I can just kind of comment this out if this is if I'm using something else. So I'm testing this function, and what I'm doing is I'm trying to express the model of things in the language. In this specific case, I'm working on this thing called a function graph. A function graph is basically like a function in any kind of code, and I also have something I call a function call, right? So if we think about C++, let me open this in another window. I'm just going to write a dumb C++ program that will explain the model of what I'm doing. So if you have a function in C++ that looks like int multiply, that takes an int x and an int y, int x and int y, right? And does something like return x times y. This thing actually doesn't do anything. This is kind of up in the air, right? This actually has no functionality in terms of the user. The user can run this program, and this will never run until the user says, "Oh well, I actually want to trigger this call and return multiply 3 and 5." And this was the concept that I was trying to, that I was implementing right before, because I had the concept of a function in my made up language, and then I had the concept of function call, which, if you'll think of the mechanics in this, it has to do some sort of patching between, the 3 into the x, and then 5 into the y. So that's basically what happens here when you're calling this function. There's some binding that happens during the call, right? Because I can also do something like, O to x equals multiply 3, 5, right? And then I'm just going to return a multiply by x and 5, right? You can kind of chain these together, and this would bind these numbers, then bind the result into x, and then bind the value of this x into the x that goes into the functions. There's some, so if you would have looked at something like a C++ compiler, and this is not a very language specific thing, so you will see some bindings that happen. So maybe you'll put the arguments on a stack every time, and you read from the stack. There's all these different mechanical ways to do this. Now what I'm doing is something more straightforward. I created objects in my implementations, one that represents the function, one that represents the call. And the call object has some way so that before, this is the evaluation function, basically every expression needs to implement. And what I did was so that each call basically goes over the function. It searches to see if the function exists, because it could also not exist. And if it exists, it's going to go over all of these, what I call call inputs, which is just like the parameters of the function. And it passes the value from the call into this. There's some mechanism that happens for this. However, I ran into a bug when I did that, because it's a, let's run the UI version for just a second again. You can see that here, like when I click this thing, this is a built-in function. It's called transpose. In this function, there are 2 inputs, right? There's an integer, this thing B. This is it's a literal music. It's a music input, and A. I don't know why it's B and then A. It's kind of weird, but A is how much, the amount. Oh, I see what happens. It's because literal is actually what gets passed into it. Yeah. So here there's actually a function call. It's a function call that has two inputs in it. I probably can just say, oh, here you go, just default. So it takes inputs as a music type and amount as an integer type. However, all of this, everything you're seeing here is basically a single function, and this single function has inputs as well. And I can click plus here, and this is going to add inputs. However, this is kind of weird, because as you can see, these inputs were also added here. This is a bug. This is not what should be happening. The reason why this is happening is because I was doing some naive implementation when I made this first run, and I think I need to go and fix it. Here's the problem, as in my in the naive mental model that I start with. The problem is the way what you're saying now is implemented is that the function itself. Let's look at this thing called a function. It's called now a function graph. So it's something called a function graph. This is the base class for the body of the function, basically. And there's also something called a typed graph, which means that you can create functions with a type, like a function that returns int, a function that returns bool, a function that returns a more complicated music type, something like that. So what I did was I used this thing called an expression map. The reason why I use an expression map is that's a concept that's used in a few other places in the language. I discovered midway through that I wanted something that would be able to be serialized. Like, you should be able to take this language, or not the language, but the preset that you make, the patch that you made in the language, in the program, and save it using something like a JSON file. And what I found was that became difficult is that if I had connections between objects, like let's say, I had a function call that calls the function, right? So there's some connection between them. I found out that it was at first a little bit difficult because at first I expressed that connection as pointers, like it had something like a shared pointer from one to another, which was good to express that connection in code, but you can't serialize that. You can't make this into a JSON file because a JSON file does not know the concept of a memory address. It just knows numbers, strings, basic text elements like that. So what I had to do, I created a map this map contains this thing called a map vector. This is just like a map that I made implement as a vector with a unique ID as the key. And what it means is that I can store this ID in the use of some function. Like let's say I'm calling a function and I'm storing its ID. Let's say the ID is 3. I can later save this as a text file. It's the function call is just going to save, I'm calling a function number 3 or with the ID of 3. And when we reload everything from the JSON file, there's no problem because there's no direct memory address here. We can just be able to call, get to the map and ask for the ID of 3. Right? That's really what this is about. And so this is good, but I have also used this not just to own the data. I've also used this as the data structure that processes the data, that shows you the little vector of processing blocks. And I think this is something I have to fix. I need to kind of separate here ownership, which can be a map and can be by ID and something like that, from the performance model, which and I need to do that because, as you can see, there's some things like the function inputs that are technically a part of the list of functions, but they need to show up and be processed in a different way. Okay, so there's a question here from Jesse. Jesse says, I am very new in coding and I am passionate and I am learning a lot every day, but what is a compiler? Oh, I love this question. And why is your code, some phrases are written in different colored, like yellow, blue, red. The functions are colored, letters are colored. Why? What do they mean to us? Is it in any code? Is it color code theme? Okay, great question. Or more than one question. So let me try to answer those. Oopsie. Let me try to answer those one by one. First of all, what's a compiler, right? When you think about a language, any language, could be C++, could be JavaScript, Python. A language needs some sort of a way to be executed, right? Because a computer language is just text. You write some instructions, but then there needs to be some way to make these instructions do something on a computer. And there's different execution models to different languages. So with C++ and languages like C++, the idea is that we want these languages to eventually become, assembly instructions on the computer, which is, by the way, not always the case. You don't always create assembly instructions. There are languages where you're creating different kinds of instructions. But in the case of these languages, we want to eventually make these the instructions that your specific type of CPU can run. So when we think about the compiler kind of, it looks at instructions that I made in code that I made up, in English or whatever, some syntax of C++ that's in English. It has names that I made up, function names that I made up, whatever. It analyzes that and it eventually creates these low-level assembly code instructions for the language, to run without the code. Because if you open a program on your computer that has been compiled, like Google Chrome or GTA 5 or something that you have on your computer, you can see that there are binary files in there that have these assembly instructions. Like, you don't get the high level code that the programmers wrote. You get the machine code that's much more efficient. So a compiler is something that that knows about how it knows about the rules of the language. It knows what does it mean to write this word in C++ and this word in C++, but it also knows how do these words translate to the execution model. So many times you compile to a binary code, but that's not always the case. Like, there's languages that will compile to another language. Like, there's something, you can compile a TypeScript to JavaScript. There's languages that would compile to C. So it just makes I guess create an execution model. There are also other languages where you do something like an interpreter. This language now is actually closer to being an interpreter than a compiler, in the sense that an interpreter. I think the technical definition is it's gonna evaluate these lines of code one by one and give you a result. This thing is, I guess this is what I'm doing now is closer to an interpreter than a compiler in that case. The other question is about all the colors that I have here, like yellow, whatever. Yes, those are things that the IDE, my text editor, is doing because it knows about types of things in the language. Like, let me just open a new project, right, with nothing. Give it a second to generate the project, and you will see that even in the hello world thing, you can see, for example, that it immediately puts some words in purple. And this is not random. This is because those words, the purple words, those purple words are keywords of the language. Like, the language decided that return is a word in the language. So when the text editor sees that word, it knows that it's special, right? And there's other things that are more contextual to the to how you use the language. Like, for example, the text editor knows that this word main, right? That this word in particular is not reserved by the language. It's not a keyword. It's not purple. I can also do, like, put another name here. It would still color it blue. That's because the editor knows that, and the compiler knows as well. Like, they know the same things. That according to the rules of grammar in this language, something that would come up after int here is a name of a function, and that's compared to something else. Like, if I just write something like I can write 5, right? 5 is a number. It's not a name. I can also do int x times 5, and x here is not a function. So the compiler knows that. It's because these are just the rules that somebody made up of how these languages work, and this is and then the coloring happens automatically. So this is really the colors. Like, it's what it means to read the color. It's very helpful because when I read this, you see I can immediately see the yellow, the red, the blue, right? This color, I don't know which color it is, dark yellow, orange, or something. So I immediately see them, and I can kind of get a good model of how do these things interact. Renzo Logudice says Rider is the GOAT. Yeah, I don't. Rider is similar to Sea Lion, like, it's from the same company, but it's made mostly for C#. But I think they also now have a version of Rider that works really well with C++ if you use one of the game engines. So, for example, if you use Unreal Engine or something, I think Rider can also parse C++ with that. And I haven't used it, but it's supposed to be working very well. So, yeah. Okay. Back to my implementation details. Just to say again, I'm working on this composition software. That software is implemented kind of like a programming language, even though the UI has a visual element to it. It's not going to be a text programming language. Like you don't see me parsing text, which is usually like number one in a compiler course. Like you read how to parse the keywords. I don't do that because it's meant to be inputted as a UI, but it is a language. So I'm just going to work on this bug that I had. The bug I had is in the function graph, I want to hold two different objects. One is this expression map, and the other is a vector of what is actually in the execution path. So this is just meant for ownership, to create things and to kind of manage them in a lifetime way. But there's going to be another structure that is just going to be pointers that will connect with that structure. So yeah. So basically, I'm going to create another structure, and it's going to be called execution. Yeah, is that what I want to do? Yeah, because this is interesting. Yeah, because I need to hold. This is basically the same, right? But also creating. This is actually. I probably should need to fix this. So there's actually. I just find a bug. Because I'm storing direct pointers here, and I probably shouldn't. I probably should store this as a unique ID to be coherent with the rest of the language. So yeah, so I can just store this in here. So I have this thing called expressions, but I'm also going to add a vector of ID, which is the let's call it I don't know how to. This is like the execution expressions or something. Something like that, like X. I don't know. A good name for this would be something like names are hard. Yeah, let's call this body. I think this is good. So this is going to be, yeah, I think this is good. This is going to be what's in the body of the function. And this thing called function connections, which I wrote in to be honest, in a very, yeah, I just realized I can probably rewrite this thing. It's a mess the way this is written. But generally because honestly, both of these should probably be of the same type, but without this like different type of called function connections. Yeah, but I have the body, and then I have the inputs of the function. That's really what I have in a function. And now I just need to do some state management, because so far I was kind of trusting this map to do everything, but I need to not do that. Like I need a way. Yeah, I need this to be separate, and I think I need to change uses of this thing to match, because now when I'm going to be evaluating this, when I'm going to be evaluating this, what I need, instead of right now, I'm looking at the map, and this causes actually problems, because that map could have things that are added that are not related to this execution graph. Yes, and I think what this needs to do is this does not need to look at the map at all. I do need the map for extracting the actual thing from the ID. So what I need to do, this should be called something like if body is empty, or so this is just all kinds of fallback. So the idea was that if the body is empty, or the body, and now I need to actually get this thing. So I need something like, I'm already going to not like the syntax. It's going to be difficult. I need to write this in a better way. Yeah. But I need to do something like, it's something like this, map body back. I think this is correct, right? Yeah. Right? Is that correct? I'm not sure. might work. So the idea is that I need to get the value. First of all, I need to check if it's empty. These are basically checks to see if I have nothing, if something fails. So first I check if the body is empty. Then I check if the last thing on the body, which is the thing that's going to get processed, because in a function, in this kind of a function, this should actually, the last thing would actually call the things before it until it manages to evaluate the entire function. So yeah, so I'm just going to do this for now. I'm not sure this is 100% correct. I'm not sure this is correct. Map.get. I had something nicer that actually fetches me the, not this. But might be fine. Maybe it's fine. Maybe it's okay. I need to be more to kind of refactor this in a nicer way. So I get the body of this, and then I don't want to touch map.back. I want to take map body dot back. Yeah, something like that. I'm not 100% convinced of if this is the best way to do this, but this is but this is not enough. I'm going to need to make sure that I'm going to need to make the creation of this be through a certain place. Like I can before that I could just go in here, click here, and kind of add this directly, but I can't do this anymore. Now I'm going to need to have something like a function that says not type template but type name, and it would be something like t create. How do I call this? An expression map. Yeah. So I think it would be something like create that takes not only the type but also creates a type name args, and then it creates with the arguments being passed in. It's a variadic template, and this would return. Oh, first of all, it would create the object. We send like to created equals expressions dot create, and I'm just going to forward everything here. But I also would need to now just put this here. Now I need to put this in the other vector. Right now I need to do something like body. Let's call it something like yeah, I probably need to make this more uniform, but I'm going to start with this. This is going to be something like body dot create created dot id, something like that, because I need to store the ID right here in the vector when I create this. So it's more maybe I don't know what to call this create. Maybe it's going like create body. I guess it's fine. Maybe I'll store the body separately. I don't know. Maybe I'll have a struct for the body. Maybe this would be a more uniform way to do this. I'm not convinced. And then I'm just going to return created. I think this is kind of the way it should work. Let me do a test with my console app, and then I will also implement stuff like remove and the other dynamic features that are needed for this. So yeah, it's cool to see people are watching this from different networks. Like I don't know where you're seeing this, but some people are seeing this on LinkedIn, Twitch, Twitter, X, Facebook, YouTube. So feel free to leave a comment if you don't understand something. I'm gonna put your comment on the screen, which will kind of patch it to the other places. and we can answer questions and stuff like that. You know what? Here's something I'm going to do, and let's see if this works. I'm actually going to put some music. This streaming software I'm using allows you to play AI-generated music. I have no idea if this is going to be good or not, so hopefully it's not going to suck too much. But let's see. Let's see what this does. Okay. Hopefully the music here is not that bad. Okay. I'll just do a little bit of the mix for myself. Hoping this sounds good, right? It's okay, right? It's okay for an AI. I don't know. Maybe it's not okay. I know what I'm thinking about this. Okay, so let's see, where am I? So now I have this thing that creates functions. I'm suspecting this is actually not gonna work. It's probably gonna crash or do something weird. Yes, so this returns 0. It should not have been returning 0, and I know why. It's because when I created this function graph, when I create this function graph, I'm directly here creating this. No, wait, these are the inputs. No, not this. When I create the multiply function, there it is. This is what I'm doing that should not be working. This. Expressions. I probably should not be touching expressions directly anymore. What I should do is do something like you know what? Here's what I'm going to do. I'm probably going to make this expression thing private, and this would make basically all these uses of expressions stop compiling, and I'll just fix them because this is not a good idea the way I've done it. Here we go. So this should actually be calling graph create directly. Let's try another track. I'm still not sure what I'm thinking about this AI generated music. This specific AI generated music that I'm getting here. There you go, this worked. So it did the multiplication that it was supposed to do. So that's good. The UI would probably now break. Here you go, so that breaks. Let's see where. Yeah, so I'm trying to... I think I passed this thing, like this map thing, in a bunch of places, which I probably should not do. I probably just passed the graph. Right? Where am I using this map? It looked like I was even using this reference. Okay, state map, remove. Okay, good. So I need the remove function. That makes sense. Let me, how am I going to do the remove function? Let's do something like, just create. Can do remove. What exactly am I removing here though? The reference. Okay, I should be able to remove the reference, I guess. But I need to move it from different places. Yeah, so I just said, wait, you control the sound. Yes, but I don't know if control is the is the best definition. The streaming software I'm using has an option called AI generated backing music. So it's not something that I did. It's just literally some function that the streaming software offers. And they give you styles, like just to give you an idea. This is so funny. This style is called R&B. Is this R&B? I don't know if I would call this R&B. You know, you can, I don't know how to call this, but it is music that will not take my stream down. So I guess it's you know what? Just for fun, I'm gonna choose classical. No idea what this is gonna sound like. No idea. Let's let it play for a few seconds and see how much this is gonna sound like classical music. Okay, so first of all, we have Jatin from Chowdhury DSP here. Jatin is, in my opinion, one of the best programmers in the world, definitely in audio. You can check out his plugins under Chow DSP. Those, I think all or most of them are free and open source. So these are very, very good projects. I'm learning a lot from his projects. Yeah, it's awesome that you've joined us, Jatin. And the comment is also very good. So it says, the AI generated music should change dynamically based on the code that you're writing. Yeah, so for example, now I have bugs in my code and doesn't compile, so it should be dark, right? It should be dark and scary, right? Maybe I should pick like some horror music for this, and then it should be very uplifting once the bugs are squashed and everything is and everything works as it should, right? I don't know what kind of music would work with a code that doesn't compile. What would be the best music for this? Tell me in the comments what perfect music would work with a code that doesn't work. Meanwhile, we'll try to make this code work. This music is so funny. Let's try another style. Let me try something like acoustic. No idea what all these words mean and how do they relate to the style. Okay, so what this should be doing is yeah, so I need to what did I screw up? Oh, the remove function. I was just writing that. So the remove function can take either an ID or a reference, which are by the way two concepts that I keep doing interchangeably, and I probably should unify them for so I have one type that does these lookups by an ID. I'm gonna start just with an ID. Yeah, because basically I need to do both, right? Basically, I need to like it's gonna be like an expression, XPR, and what this is gonna do, this needs to destroy both, right? So it needs to remove these from the body vector here. I hate this double bookkeeping here, but I didn't find a better way to do this. Let's do something like body, right? I think I call this like something like remove all matches of expression.id. Expression.id. And then I need to what was it here? Expressions. I have erase here already. Remove by ID or something. By an int. Oh, I have to remove by the expression. I think that's fine. So I should be able to also do expressions. Remove the XPR. So these are this should be the remove function. Let's connect this to the UI. Where was I? Not here. Let's see what doesn't compile. It's going to be easier. I love compilation errors to just tell you what it is you should be doing. So I will just do something like state graph remove. Do I have another call for this? Oh, good. So this needs to listen to the map, but I don't need to listen to the map directly. Instead of, I'm going to have it listen to the graph.body. This is a good start. Okay, this thing called plus block needs the map. I don't want to give it the map. I'm just going to give it the function graph. Oh, it's expressions. Function graph. So now I'm just doing some bookkeeping of making sure that the type that I'm passing down through the UI is actually the type that manages this, which is the graph, and not the lower level container, because now there's actually two containers that needs to be in sync. One handles ownership, the other handles the execution graph, which is a little bit different here because of these function inputs that are kind of a special case. So what is this doing with the map? Okay, so this would just be the graph. Yeah, so here what do I need to get here? I need to get there's no map anymore, it's just the graph. But I need to, okay, so this should be the graph dot body. It's probably just the body. Body. I can just do something like, yeah, because now I need to get this from the map. So I do need to do that. I do need a way to connect the ID to the actual thing. So I can do something like, but no, I can just do like expression get. This is a pointer because this could be null, so it should be something like get, which will take an ID. It will just return expressions. I think this should maybe just work, right? This would return the type. Yes, this would do what I need. Should be const, right? Good. So then I could just do body dot get from graph dot get state graph get body index. Yeah, that makes sense. Yeah, I think that's correct. I think that means that I can probably at this point just switch this to a range-based loop. So I can just like O2 ID from the state graph from the body, just basically. I just need to go over the body, and each of those IDs I would just need to get. I probably should check that this actually exists, although I don't think there's a chance for this to not exist, but just for guarantees. So this is a UI code that this gets called whenever something gets added or removed, and then it does a loop over the different things in the body and creates a single block for each one. Let's see if this is correct. Okay. Oh. Parameter ID is what's ambiguous about this? Let's see what these error messages mean. God, this music is so weird. I know how you're feeling about this. It just keeps my brain keeps thinking. I'm gonna do something called chill hop. I have no idea what's going on here. Oh, okay. So this is something like XPR ID. The actual error though is that I was still trying to use, oh, here we go, expression map. So I can probably just do this with the graph, right? I can just do the graph directly. I need this thing, I can just do graph arrow create. Go, file list of errors, because I need to do reference here. This could be a pointer. I mean, or this is a pointer. David Frick says, thanks for walking through this process. Yeah, of course. You know, the interesting thing about what I'm doing here is this is uncharted land for me too. Like, I know how to fix C++ code, but I've never written a programming language like this. I'm learning this as I go along, and I'm also trying to figure out what it is that I want it to do. Same with Orr. He finds out, you know, what he wants to do. He tells me. I'm trying to think how this could be done. So we're in the process. Like, this is very much meant to be not like some show off of a finished product. So yeah, so this is now compiled. Now let's see if my bug was fixed or I'm going to have a nasty crash. Yes, almost. Okay, almost perfect. I just found out another problem, but I can probably fix that other problem. It's less important. The problem is, you see the letters, you see it started with D. That's not good. Like, it started with D because A, B, and C were already created. But this is kind of stupid because these are separate lists. Like, there's no reason why these would have. What I probably can do is I can kind of force an input to have. I call this thing an I/O because it's an input. It's an input when you call the function, but it's an output into the rest of the function. So I call it an I/O. It can be looked at as both directions. So what I need to do is I need to find some way for this to be organized. You know, not with the regular ID system, or at least. So either I'll hold a parallel ID list of just the inputs. That's one. Maybe a good way to do this. But also, I think what I also want is to have it be something like I don't know what's going to be a clean solution to this, but I'm gonna do the non-clean solution. But first, I'm going to commit this and says that what I fixed was so I moved function called body. Into a separate structure that's different from the ownership object. I think that's pretty true. So there's a question here from Jesse. Jesse asks, and do you do live quite often, or is this an exception? I'm trying to do more often. Like I've done. This is my second stream today. Depends on how you look at today, but generally it's the second stream today. I've done 2 streams yesterday, I think. So I'm trying to do them often now and kind of see how this works. I'm really hoping people enjoy these because if this works, I might just do it every day. Because I'm trying to be transparent and share everything and be like I like this process of talking with you, answering your questions. I like this. So I think this is going to be a common occurrence. Depends on how I'll feel about this AI music, these music tracks. I don't know what to do about this. I really wish I could play the music that I usually listen to, but I'll get taken down immediately if I do that. But the AI music, I don't know. Do you hear that? Like, what do you think about these tracks? yeah, it's even possible. In some or Lubyanika, my partner, he's joining me in some of the streams to do design. He's doing the design and project managing and stuff for all our products. So he's I don't know if he's going to come on the stream today, but he was on the stream before, showing his Figma magic and how he prototypes things. Yeah. Yeah, so as I said, just to give you a recap for people who are tuning in lately or something, we are working on a project that's a music composition software, but it's meant for stuff like algorithmic composition, where you express rules of music. So, and because of the nature of this kind of program, it's built a little bit like a functional programming language. So you'll see me implement things like functions, implement things like a function call. There's not going to be any classes, fortunately. It's only going to be pure functions, but still there's a lot of quite heavyweight objects here because of the interaction with the UI. Jesse asks, what kind of projects or exercises? Let me put myself up here. So what kind of projects or exercises would you recommend for a beginner looking to gain hands-on experience in coding for audio software? And what do you wish you had known or focused more when you were a beginner in this field? So, so I would definitely say that, in my opinion, and I'm saying that somebody who hired people for audio jobs as well. I think the main thing to do is you want to have a really, really good grasp of C++. Or you can do some other language, but I think that this is the main thing that I think you would be required to show. And I think any project you would do that's fun for you in this context is great. Like now there's libraries like Juice. You can get Juice and start immediately working on a synthesizer or effect or whatever it is. Like I would just think of some idea that you like, but I would make sure that you put a lot of emphasis on knowing the language. And by the language, I mean, there's two things. One is you want to know the syntax, like you want to know how to create classes and how to create functions, and maybe you want to learn how to work with pointers and references and templates and lambdas, stuff like that are built into the language. But also, you really want to learn like the way code is handled, logic. You want to make sure that you know the difference of what it means to work with a vector of pointers or a list or a vector of values, and kind of realize the different semantics that happen as a result of these different data structures. I think that's very important. I don't think you have to be like an expert in DSP algorithms right off the bat, but it would help if you can tell me, if I give you some piece of code, like if you can tell me, hey, what happens there? Is memory being allocated? Is this being copied? Is the copy constructor called? Is, stuff like that. These are things that really help to understand complexity in code, especially when it comes to do with stuff like pointer semantics. That is something that people have a really hard time grasping, like the fact that a classic example is if you have something that references something else that kind of observe the memory address of this other thing, you need to make sure that thing is never moved, right? And the thing that observed the memory address cannot know that it moved. It's just a memory address as far as it was concerned. Like it knows that, like for example, if you have a UI object that kind of observe something, you need to make sure that thing is never moved while that UI object is alive. Like you have all these mechanics that if you know, that's gonna dramatically increase how you can be productive in the space. And I would do it around anything. I'll go to a Juice tutorial. There's a great channel called The Audio Programmer. I'm also a guest lecturer on this channel. We do tutorials that are meant for beginners or intermediate level. People like Jatin Chowdhury, who was just here before. He's one of the lecturers there. He does amazing lectures. So yeah, so there's amazing things that you can just kind of get if you want to get a starting point. I would just go there. My personal channel also has a few tutorials, like I did a few like streams more meant for beginners. So yeah, absolutely, there's a lot to do. Hopefully that answered the question. My ear hurts. I forget another. I've been using these headphones, not these specific ones, but this model of headphones for years. They're comfortable, but I don't know. Maybe I need something else. No, I don't know if people can tell me what they're using for headphones they want to wear for many hours. What do you use something that kind of? Because I think once I started wear these glasses, then I realized that it feels a little bit different. Like the angle is kind of different on my ear. Does that make sense? I don't know. Yeah, so I'm in the market for new headphones. Let me know what you like that sound good, like studio headphones, but also are super comfortable. If you can recommend to me in the comments, it would be awesome. I would usually recommend these. These are the AKG K240, which are they're classics. They're great. I use them to mix and stuff, but I don't know. Okay, so back to my implementation here. So Jesse Bilm says, as a music producer, I use Audio Technica, very comfortable. Okay, yeah, can you give me like names of the name of the brand? I'd be happy to look it up. I'm more familiar with Sennheiser headphones, but the Sennheiser ones that I've had, the HD, what's it called? There's one Sennheiser model that I like better. One was Sennheiser HD HD6. I thought those were pretty comfortable. They're pricey though. Like, they're much more pricey than these ones I'm wearing now. They had this like really nice, comfortable padding around the ear. I did find that I was kind of sweating in them, like they were kind of making my head hot, which is, those are better in this. Like those are like kind of loose. Like the actual ear thing is not stuck to my ear. But maybe I should be open to something like this, something different, just because I definitely feel like I get a more balanced tone with these compared to the HD6s, the Sennheiser ones. But there are higher end types. Oh, maybe it wasn't HD6. Maybe it was HD. Maybe it was HD600. Yeah, HD600 was maybe the right name. Confused about all these models. What's HD6? The ones I had were like pretty comfortable. I don't know if it makes sense. Sorry for the gear end here. Okay, so let's take a look. Just browsing through the chat here, see if I missed something. so now that I've done this, you see the problem. I've had this problem with my with the letters, and maybe this would be time to clean up this. Clean it up because there's some mess here in how this is stored. Like the function connections hold an expression pointer. This is not going to work so well. This might not work so well. I think I need to clean this up so that it's kind of more uniform, the way the body and the way the inputs are kind of connected, because both of these are really, yeah, this is kind of a mess. This is not nice. Okay, I'm going to remove this. We're going to remove this whole struct. I need to do something better. Yeah, because really, whatever is in the body, or maybe I will reuse this. I'll can create a generic version of this. Because what I need to do, the problem is this thing called expression map. That's really this is a horrible bug here. Not sure how that ever works. This should be here. This should be above this. Otherwise, it's not going to compile well. But yeah, this is not good. I need so that this vector of IDs and this thing, function connections, which should probably also be a vector of IDs. Both of these are basically just, they hold IDs to the map. And this is, by the way, kind of such a common pattern here. So I have to find a clean way to do this. Like so much of my code right now is this storing of the ID, but then fetching it from the map. Storing it from the ID, then fetching it from the map. And I only did that because of this problem of being able to store this as a JSON thing and kind of pass it around without the pointer to the map and then recover it again with the map. That was really what it was about. So this question. Should I go learn in Timon High School? I live in Israel. Limon High School? Limon, maybe? I learned in Limon Music College. Is that what you're talking about? I don't know if it's, Limon is a music college that I went to. It's in Israel. Okay, so this is a great comment. I love this comment. I wish I was so bold as to delete my code instead of just commenting it out before writing new code. Okay, this is okay. I'm gonna go on a rant here. This is gonna be my moment on my moment of streamer rant. Let's bring myself here so I can do the streamer rant. There's a thing called commenting out code. You have code that runs. You comment it out, and then it stops running and you still see the original. And it's almost like, it's one of these things that you do very often in debugging. You're like, oh, let's just, let's see what happens if this function doesn't happen. Let's comment it out. But if you think about a code that's going to stick, commenting out is actually not good practice. I think you should not have comment out code left, ideally. Maybe sometimes you can keep it for whatever, but I would do whatever you can to not have commented out code after you finished what it is that you finished doing right now. And here's why. Comment out code, first of all, leads to confusion because, let me show you. Like, first of all, you might, let's say I'm looking at this piece of code. Let's say there was a piece of comment out code here saying something like, calling another function, I don't know, calling like body dots. Other function. I don't know. There was something else here. Expression. There's something else. Some other function. First of all, are there any guarantees that this function compiles? No. Let's say maybe in the past this function existed, but now it's commented out, so the compiler is not checking for this. This is basically this could be a bug. This could it's possible that whoever commented out because it crashes the entire program and deletes files. I don't know. This could be harmful. What is this code? It's not tested. It's not compiled. It's almost like I get that you need to do this when you're working. You need to observe this, as a local backup. But once you did make a change, commit this to source control. I don't know if you noticed, but everything I was changing now, like for example, just let's look at my Git history, right? I have every change that I've done is backed up in a commit where I can see the diff. Like I can go here and see, I went to this thing, you see, and here's what I changed. I was working on this update blocks function. I can see the diff between the old and the new, right? I don't need to have the commented out code. I can always go back to this, which I will do often, by the way, and look at the previous version. Or maybe I can even look at a few previous versions, not just the last one, right? I can go to look at this. I have one from 17 minutes ago. I also have one from 6 in the morning or 3 in the morning. Don't ask why I'm coding at 3 in the morning, but but here I was changing this other function, right? And I can also observe the changes of history. Like I can go to say, hey, give me the history of just this file, right? I can also do that. I didn't open git show history, right? This is the history of just these files, and I can see all the changes. So I don't need to comment. I don't need a code that comments out. This is better than commenting out code because I can go back to this version. I can actually recall my code the way it was yesterday morning and compile it. And it's going to compile. I know that it hopefully compiled back then. So I can have a working version of that code. And because usually code is not local. Usually when just like I showed with this commented out function, right? When you think about how this happened, when this function existed, it probably worked because other file had that function, and who knows what happened there, right? So it's this to me is not very helpful because it's local. It doesn't talk to other files. The Git history is what you should trust, right? You want to be able to navigate your Git history. You want to be able to do clear commits as well, like commit often, commit short advancements, so that whenever something happens, like you made a bug, you're like, oh, let's look at the history. I look at this thing. The history is something I look at so often. Okay, so there's a music question here. What did I mean? Okay, so the question is, what did I mean is, what maslul did you do in Rimon College of Music back in the day? Should I go there or time change learn on YouTube on internet? What is the JSON? Okay. So I'll explain this. These are two really good questions. So Rimon School is a music college that I went to. It's awesome. I used to teach there as well. I still do projects with them. Like when they do hackathons and stuff, they do music tech hackathons. I'll be a mentor there. I just did about a month ago. It's a great school. When I was there, I wasn't yet programming, so I just studied composition. Now they have not just all the music classes and jazz classes and music theory, they also have a programming class that you can take to stuff like it. But obviously, it's not a programming school. So if you want to learn programming and focus on that, I wouldn't go there. But if you're into doing music and kind of learning, aside of tech and code, I think it's just great. Rimon was just so great to me because I would be inspired by all these musicians. Like so many good musicians were with me in my school. I went there and there was this singer called Tammy Sheffer. People from this channel would know her. From my channel would know her because I recorded a few songs with her. She was, I went there and she was just the best singer in the school, and she would just perform. And I would just see her, perform with these ensembles, and she was so good. So, like, people like that are so inspiring. They're really like the power of a music school. Like, you go there, you see people who are, trying to hone their craft, and you learn from how they do. And I met Ray Livnat, who became, the singer of Project RNL. I met all these, unbelievable musicians that are. Became like part of my identity later, like the connection between them. The other question is about the JSON file. Okay, I'm going to answer this. This is important. It's going to come up often. JSON file in case people don't know, it's just a text file. It's a format of a text file. Is there an example of a JSON file here somewhere? I'm just Googling, JSON file example, just to see if I can find something that I can copy paste, right? There you go, that's good. So I'm gonna open like a text editor. Yeah, a JSON file is something that looks like this, right? It's just like a way to input data. You can see that it's just text data. There's nothing super interesting here. There's ways to input data. Like it has markings for an array of data, and you have different types of data. But it's basically a big chunk of data, and the JSON is kind of intertwined with JavaScript. Like it's kind of almost all the internet works with JSON and a bunch of other languages. So it's just some text way to represent the data. And the reason why I cared about this is so let's say that you make a patch in my program. I wanted you to be able to save that patch. I wanted you to be able to, let's say you write a bunch of like these blocks, instructions for your music, and then you click save, right? You want to be able to save this and open it later on another computer or something. So that means that any data that you put in needs to be represented in such a way that can be saved in some text format like JSON. And the problem I've had with using something like pointers hold a memory address on your computer. And not only it holds it on your computer, it holds it on your computer in this specific run of the program. Like let's say you run the program and I'm going to store some memory address of some variable, and you stop the program, you run it again, that memory address will probably hold something else. Like there's no guarantees that it's going to be consistent. So what I decided was in my design was to switch to something that in the state of the program holds IDs. An ID is just some unique number. It could be 3, could be 5. Ooh, getting a word. There's no sound. Is it true? Is there no sound? Hello, hello? Doesn't have sound, right? Oh, my sound stopped. That's interesting. Okay, how long was I talking with no sound? Where was I before the sound was dropped? I was basically ranting about the meaning of a JSON, format, and I just said that it's a text format that just represents data. I need to find a way to store the model of the language into a JSON file. In a real computer language, the code itself is a text file, like this C++ code thing is a text file. So when I click save, this gets saved. But in a visual language, there needs to be an additional text file that saves whatever it is that you did. It's not going to look like code, but it needs something that can be later recalled. That's really the So hopefully this makes sense. Like the JSON file is just data, just text organized in some way, but it's just text. There's nothing magic about it. I just needed to struct my code so that it's convertible to a text format, so it doesn't hold any magic of pointers. Even though I still want to maintain connections between objects, right? So for example, if you have a function call and a function, the function call needs to know exactly which function it calls, right? So that if you hit save, quit, do something else, come back, you load, and the connections kind of get restored. So this is what I did with this ID system. I really want to shout out to Asaf Dal Sagol, who is in the chat here. Asaf is one of the best people I've ever met in my life, and he's also my mentor in all of this. Asaf has a company called Polyverse, and they make the best plugins. Asaf, actually, if you're if you're around, maybe we should do maybe we should interview you on this stream. So if you're available like now or in an hour, we should probably bring you in to do this, because Asaf is, he's brilliant on so many levels. He's brilliant as a musician. He's orchestral arranger and composer and cello player, but he's also an electronic music expert who knows everything about synthesis and about filters, and he codes all these amazing DSP filters that are used in plugins like the Polyverse, Filterverse, and Supermodel filters, and Manipulator, which is a plugin that kind of changed my entire life with how expressive it lets you control vocals. So Asaf is the best, and Asaf is the best, and all of the Polyverse plugins are things that, even if I didn't know Asaf, whatever, these are the plugins that I always use. Like Supermodel is my go-to filter. I use Supermodel all the time in mixes, lately even. And Manipulator is like I always perform live with Manipulator. I record with Manipulator. Like these plugins are just part of my life, and this is not even goes beyond who Asaf is and what an amazing person he is and everything. So you should know Asaf, and you should check out Polyverse. And Asaf, let me know if you if you want to go on the stream. I can have guests here, so I can bring you in whenever you have time and you want to shoot the shit live. That would be fun. And people in the chat are saying things about Polyverse. We have a lot of Polyverse fans in here, rightfully so. Right? Yeah, you got to be using Polyverse plugins. Really, it's so good. Yeah, so Asaf is up for it. So you know what? Maybe we'll take a break from this. It's gonna be fun. Maybe we'll bring in Asaf. Asaf, are you ready to go now? Yeah, I'm going to write you on Discord if you want to do that. This is going to be fun if I bring in Asaf. Okay, that's awesome. Okay, here we go. Let's. I'm going to send you a link. This is great. So invite guests. Swartek says you missed the second stream. Oh, don't worry about it. Oh, you know what? Second stream was a mistake. Second stream never happened. Second stream was a bug eventually that happened. So Asaf will be joining us shortly, and he will show some of the amazing things that he's doing. This is so great. Asaf is the best. And Jesse says that Asaf was also in Rimon. Yes, that's actually how I met Asaf. So I'm gonna, while Asaf gets ready, I'm gonna tell the story of how I met him. It's such a cool story. This is a cool story. I'm gonna tell it. So here's what happened. Asaf. First time I heard about Asaf was through Jordan Rudess. People working with this might know I've been working with Jordan Rudess for many years, recording music and working on different projects with him. He's also an artist of Modalics, which we really appreciate. Like he's been awesome, to us and to me. And definitely one of the best people, one of my best friends. And Jordan was telling me, hey, do you know this guy called Asaf? And I'm like, what? What's this guy? And he says, yeah, he's great. Like he talked to him about some things, and he said he's so smart. And I was like, okay, well, I gonna check this out. What is this? And I was, I don't think I connected with him directly, but then I was coming back to Israel for a while, and I was in a meeting with Yuda Eder, who still is the president of Limon School, and he said, "Hey, you should meet Asaf. Asaf is so smart." He was also raving on us. I'm like, okay, I need to meet this guy. He's everyone are telling me that he's so good. So I met with him, and I think let's see what he says about it. But I felt like we had this like instant chemistry. Like we would just look, here is Asaf was joining us, or is joining us. Let's see if I can bring him in. Hello. Look at you.
Wait, I can hear you in a large delay. Now I have to figure out
because you're hearing me both in the stream and maybe are you watching
crazy
the stream
delay.
somewhere?
1 second.
Okay.
One second, let me figure this out. You continue entertaining, and I'll be with you in a second.
Okay. So I'm going to continue to tell you a story about Asaf. So the story was that we met and we started just hanging out at Asaf's house. We just started to have.
I'm good. Yay.
Okay.
Now we have low latency. Awesome. Now I can see you. I can hear you.
Yeah. So somebody said Asaf is too loud. I'm going to make him a little bit softer. Talk for a second.
Let me make myself softer. 1 second. Hey. My speaker can go down. Okay. Is this better?
Yeah. Can you see the comments? I'm going to bring up the comments on screen so you can see what people are saying.
Yeah, I can see the comments. Yeah.
Okay. Are you able to read the entire chats like I do, or can you only read what I'm?
I see whatever is in the restream.
Okay, good. Okay. So
yeah.
I just turned down Asaf a little bit
Says
more.
Still too loud. Hey, 1, 2, 3, ABC. Am I clipping? I don't think I should be clipping.
I don't think you're I don't know. I don't see a meter. The streaming software doesn't give me every detail that I would want. Okay. Hopefully this is better. Hopefully Asaf's mix is better. I can't really.
Hey,
tell.
ABC. 1, 2, 3. Testing.
ABC.
My nasal froggish voice is piercing through your speakers right now.
Yeah, so I was just telling the story about how we met and how you were recommended to me, by people, and then we started hanging out at your house. We started to just hang out and talk about, music. And I remember you were trying to teach me about electronic music. You were playing me all these artists, and
We were both not coders at the time.
You were not coding?
I knew how to code, but my profession was an arranger and a teacher, right? So we were both in a completely different situation than now.
Yeah. So yeah, Asaf. Okay, so it says you're 15% louder.
15. Make it mathematical, please.
I wish it would show me. It's funny. In the last stream, or when I was, I think maybe I've shown you this. There's this project on Reddit that people try to design the worst volume controller ever from a UI perspective, and it has things from things where you click and it just does a random volume on every click, to things that have physics, like you try to bring it up, it falls down back again. Some people try to show the volume knob as a list of all possible volumes.
I would just add a mode where you add volume and you get extra hiss instead of changing the volume of the actual person speaking.
There's a feature of a real mixer though, right? If you have like a hardware mixer, just bring up the wrong fader.
Yeah. I got inspired from somebody we know.
Let's see if I can. Now that I'm not streaming, I can probably do. Let's see if I can put you on my screen in front of me. Oh, good. So now I can look at you. This is better. I don't need to look like this to see you. This is better.
Yeah, it's like a phone call now.
A phone call. Yeah. So So what's up with you? What's going on?
Doing some spring cleanup in the code. I'm just making now a hideable component, which is basically a container that takes in a component. You initialize it with Lambda, and the Lambda remembers all of the variables that it initialized with, and then you can hide it and unhide it by destroying it.
Yes. I think that's exactly what I do. If you actually destroy the component, or when you destroy your component, it makes that thing invisible.
The hideable component is the one destroying the component. It is a component by itself that houses a custom component.
Yes. Okay.
So the hideable component never gets destroyed, right? It's just an object, like I used to work with.
Yes, exactly.
Right?
That's what I do. Yes.
It's a typed one too, and it also has asserts to make sure that it is a type of a component that is derived from a component. So you can kind of create crazy stuff with it. So it's a typed component will accept any kind of component that you create, and it will delete it, it will resize it, and it will handle all of its life cycle for you. Yeah. So I'm glad about this one, and it's going to be very easy to move from just hiding stuff with ifs and size 0 and visible and all that stuff to completely just deleting it. Because, yeah, as you know, I have the new param updater listener thing that I just don't want it to be aware of the life of the components. Just like update
Awesome.
whenever you want.
Yes.
Yeah, so things are looking good.
Yeah, it's awesome. It's awesome. So,
Yeah.
I mean, I know a little bit about it, but people in the stream might not know. Is that you're basically modernizing now the entire Polyverse code base, right? The entire library that powers all of your plugins, not just a specific thing.
Yeah, slowly but surely, I am removing lots of bulk and junk from the code and making things simpler to maintain. And removing lots of bugs on the way too. So yeah, a lot of spring cleanup.
Spring cleanup. Yeah, because people don't realize, one of the things that maybe it's obvious for people who worked, in companies like that, but a lot of the times when you start to have multiple products, it's not like you code the product and it gets thrown out. It's that code is still maintained, still it's still sharing code with your other plugins, and you still want to make sure the
if you know what you're doing.
If you know what you're doing. No, but even if you don't, let's say you never touch the code. That's another thing that people also don't realize. Even if you never touch the code and you keep it as it is, the world around you changes, right? The Xcode compiler is a new compiler, 2 years from now, right?
Xcode is the worst offender from all of the software. It's like, from now on, we're going to do things differently. And you're not going to like it, but you're going to get used to it.
Yeah, so people think that if you just don't touch the code, then you're stable. No, there's no guarantees. Also, there's changes that happen in the OS, right? Like, or like, for
especially
example,
in macOS.
Especially in macOS, right? So or iOS, right? All these Apple.
Yeah, because they want you to buy a new computer every 8 years at least, right? So after 8 years, it's like no more compiling for that system anymore.
Well, not compiling. Sometimes there's runtime errors. Like sometimes there's something you do, especially on like UI, like window management or something, and then you're like, oh, this is not going to run on a newer OS. Like it's going to compile, but the user is going to click this thing and it's not going to do what it is that it used to do. Maybe a permission thing was added, like a security permission or something. And so just not touching your code is not even an option. Like, you have to keep compiling your code and test that it works at the minimum, right? If you wanna do a new version, or you want to do an update.
If you don't want to get effed by an update to macOS that makes all of your plugins have a bug all of a sudden,
Yeah, and
which Apple love to do that.
And Windows had changes too. So one thing that happened not so long ago, like a couple of years ago, there was a thing to do with the static linking of the standard library. Do you remember that? It was a big fiasco. Let me explain the story behind this. There's two ways in Microsoft compiler and Visual Studio. There's two ways that you can select on how you want to connect with their implementation of the standard library. You can either build it statically into your code, or you can link it dynamically. And dynamically means that the user has to install it, and you can see that some plugins or software or stuff like that, they would have you install something that looks like the Visual C++ redistributable stuff. Like, you'd have this complicated installer, right, that would install this. This is why. So, and you would ask yourself, why wouldn't I just do it statically? Why do I even need to have the user install this big installer and stuff like that? And the reason was, up until recently, if you didn't do that, recently is like 2-3 years ago, if you didn't do that, if you did statically and you made it simple for the user, after a certain amount of channels, your code would just not work as it should. Like, some crazy things would happen. I think it would be like, I forgot the number, but it was something around like 100 channels.
Channels of what?
Of your plugin, like instances of your plugin. Like, let's say someone made a track with...
I wasn't aware.
It's a crazy bug. It's such a weird bug. And, it's rare because, for example, I don't know if people would get to that number with a creative plugin, right? Because I don't know if you get
probably not,
right? But with a mix plugin, there's actually a lot of mixes. That's how I learned about this, because in a mixing, if you have like a channel strip, that sometimes people even use that channel strip on all the tracks in the mix, like the same thing. So it's common that they would have 200 channels just with the same thing.
Yeah, with compressors and
EQs or something, right? So that bug would be so weird. So basically you had to use the DLL, but then you had to make the installer weird. And about a few years ago, they fixed it. And by fixing it, I just mean they raised the limits to some crazy limit. So now I think if you build statically, it's only an issue if somebody puts like 5,000 tracks. Like now the number is way beyond anything reasonable. So it's not a problem. Super weird Microsoft
That's weird.
issue, yeah.
Yeah, I hate maintaining stuff. Give me the creative process.
Yeah, these are such interesting dual ways. So
wow, you must have a very powerful computer, David.
Yeah, I wouldn't be surprised if I've used 100 instances of Serum on a couple of projects. Yeah. By the way, I don't know if you know, but I worked for Xfer for a while, and yeah. So I wouldn't be surprised. Yeah. So 100. I forgot what the exact number it is. If I can look it up. But by the way, to give you a crazy, when they fixed it, it's not in the compiler. They fixed it in Windows, right? That's what. So if you have some old version of Windows, you still have the bug. Like Windows 7 probably has the bug. So it's not like the developer can fix that for the user. The developer would have to tell the user, hey, go update to like the latest Windows 10 or
right.
Yeah, it was a very bizarre thing that happened. But Windows is, like you mentioned, they're generally good about keeping things stable, right?
Windows are much better than macOS, but macOS, it's not about better or worse. It's on purpose. They're doing it to get people to buy more computers, or you can say that you can claim that it's so that their code is cleaner. But knowing Apple code and knowing how messy it is and how undocumented it is, I don't buy that one.
Yeah, I'm just looking here to see if I can. Can I add a name display? I think I should be able to have. Should be an option here where I'm saying where I can have your name under you. And we can see exactly where that is. Yeah, so stuff. So do you want to say something about the more recent polyverse stuff? You want to talk about maybe filterverse or something?
Um, we're making a plugin.
Yeah.
It's a filter. Has lots of filters in it and modulators and whatnot. And the goal is to, on one end, make the best bread and butter type filters. Like when we make a filter, we put in a lot of attention to the smallest, tiniest details on how is the resonance controlled, what kind of character does the filter have, what kind of nonlinearities are in the filter, how can we use it for sound design in a more musical and pleasing way. So a lot of filters have of people call filters digital because they don't have controlled resonances. For instance, a lot of filters that don't have self resonance have a linear type resonance, and that can just explode in volume, and it sounds shrill, and it just doesn't sound so good. But it's not about digital or analog. It's more about what kind of nonlinearities are you introducing to the filter? How are you controlling that resonance? We use some different types of saturators in different places in the filter. What kind of topology is the filter using, and so on. So we're not trying to imitate anything analog, but we are using some analog topologies to achieve some of those differences between the filters and digital topologies as well. But the other end of the spectrum, and that's where my passion really lies, is we're trying to make filters that sound completely new and fresh, that nobody has ever heard before. And those are the things that make me tick.
Can you explain what does it mean? What does a filter topology means?
Sure. So some filters can create their resonance by feeding back themselves. For instance, the most famous filter topology would probably be the ladder filter, what Moog uses. And basically, I'm not going to go into the analog part of it, but basically, it's several 6 dB filters routed serially,
Okay.
one after the other. And to achieve resonance, you feed it back to the input.
Mm-hmm.
And if it's a high pass, you just feed it back positively. If it's a low pass, you feed it back negatively, because negative feedback will tend to boost the higher frequencies. So if you have a low pass filter, the highest filter frequency of the low pass, that's going to be your resonance point. If you have a band pass filter and you do the same thing, then you can boost like one end of the band pass. Like if this would be the band pass, the resonance will come on this side. And if you do a positive, it will come on the low side, positive feedback. So it depends on the feedback and where it is. Other filters, like the state variable filter,
Wait.
can create several
Before
filters at the same time.
you go
Yeah,
into the state variable filter, I want to ask you about the. So by topology, do you mean it's something like the architecture of
yeah.
of the algorithm of the filter?
It's basically how the architecture is much more involved than just the topology. Topology just means like how do you how is the general signal flow in the filter. The architecture will also include the way that you implement the topology. There's different mathematical ways to implement the same topology, and the architecture will also include things like nonlinearities, and small tweaks, for instance, to make it sound better, um, and so on and so on. So the topology itself is just mostly the signal flow within the filter. And that can be interpreted as many things. I personally like to simplify it to just like a signal flow. Yeah. So I'll even make a drawing
Okay,
for you to
awesome.
understand. Okay, so and visualize it in your head.
Yeah. So I'm just going to say to people who are just joining, we have here Asaf Dal Sagol from Polyverse. Asaf is probably, you know, probably the greatest filter designer in the
No, I'm
world.
not. I'm
Yes,
not.
you are.
Nobody is the greatest at anything that's art related. We're all colleagues. There's no competition. You
Right,
can't have enough filters.
right, right, right.
Go get Cytomic the drop. Go get Diva. Go get the best filters in the market, and also get Filterverse. Um, so this would be a drawing of a topology of the ladder filter. Very
Mhm.
simplified, yeah. So there we go. Let's see if it focuses nicely. Yep.
Mm-hmm.
So we have low pass 6 dB plus 6 dB 12, 18, 24 serially. This is the, oh, you know what? The output, right? So this would be the output. And here we have a feedback path. It's
Mm-hmm.
a negative gain. This is the multiplication, so that's gain. And it goes back to the filter, and this is what creates a resonance. Very simplified.
When you, when
Another
you
way,
when you say multiply by negative, it's like a phase invert.
yeah,
Okay.
yeah. When you multiply by a minus number, it's you inverse the phase. Um, it's not a phase shift; it's a phase inversion.
Invert.
There's a big difference.
Yeah.
Another topology that can happen is that you can say, "Hey, I want to create several filters." Um, one moment. I don't want to get this one wrong. State. So,
But by the way, feel free to let me know in the comments if you
there
have
we go. I
questions
got
for
it.
Asaf.
And so here's you know what? I'll just share my screen.
Mm-hmm.
Why not?
Why not?
Can I share just a tab? Let's see.
Mm-hmm.
Yes. Okay. So this is a website that I really like. Ear level. Here we go. So this is a website I love. It's called
Oh
the
wait.
Ear Level.
I need to add your screen. The screen here is like a separate participant. Okay, here it is.
Yep. This is Ear Level. It has lots of very simplified articles that allow you to kind of grasp the basic concept of DSP. That's where I started. I'm in a completely different place right now, but this one is very nice for whoever wants to kind of intuitively understand the basics of filter design. And here he has a, let's see if I can zoom. Can you see me zooming in?
Mm-hmm. Yep.
Awesome, cool. So here we have a topology of a filter, and the Z minus one is basically a one sample delay because this is an implementation a very naive implementation. You can implement this in a different mathematical way, and you won't really need those. But this will create a high pass, a band pass, a band reject, and a low pass. And even you can add a peak if you just put a minus here, add the output of the subtract the output of the high pass and the low pass, and you'll get this kind of all pass with a peak. So this is a different type of filter. It sounds different. This is a 12 dB filter. You can put two of them in series to get a very resonant filter with lots of more options. But it will output those filters in parallel, as opposed to a Moog ladder filter that will have to be done. You'll have to do the high pass, the low pass, the band pass separately because they have different topologies from each other. So each filter has its own topology, and you can really, this is a deep dive. You can have countless types of topologies. You can tweak them, and that's the best way to get different sounding filters.
So interesting. Do you wanna maybe explain this in the context of one or two of the filters in Filterverse?
Well, the main filter that we have, the filter that Filterverse loads with, is, should I load Filterverse for you guys?
Yeah, let's do that.
Let's see what we can do. Stop sharing. Let's. I need to compile a non-debug version.
It's a classic problem, whenever I have I'm demoing somebody the plugin, I have some crazy development version of the plugin and nothing works, and
yeah, it's going to crash. Obviously, we know it's going to crash, right?
Yes, just like Bill Gates and Windows 98.
Oh, maybe I can't. One second. I'm just going to delete a bunch of code here, so I can compile it. Okay, while I compile it, and before we run logic, so a topology does not tell you how the filter is going to sound. It just gives you options to tweak it in certain way. In certain junctions, you can add nonlinearities. You can control the mixing of different stages. You can use the idea of a topology to create a new topology that has never been done before. Yeah, we're halfway there in the building process. And you can go inside a topology as well. I mean, just talking about a 6 dB filter, that can have different topologies. This has a direct form 1, direct form 2. You can make it zero feedback delay, zero delay feedback. You can make it maximum phase, minimum phase, bilinear, all kinds of different topologies. Oh, you hate. I've never had to type my password when I publish my app.
I think the first time you have to, when you do what's it called, like notarize, but it's just once. There's a button that says always allow. You just click it and that's it.
I don't use the notarize from there. I have my script to build everything, and it just works.
Yeah, the script should ask you once to use the password, but only the first time.
It doesn't ask to use the password. It asks you to use the maybe password, but not my password.
Yes,
it's the password
it's
for the. It's the password for the developer.
Exactly.
It's a signature password.
Yes, exactly that. Right. So there's ways to do this with a script, exactly like Asaf says, that where you can put this thing in the keychain. There's a thing you can create. You can use. There's something that if you go on your Apple ID, I think there's a thing called app-specific password that isn't your password. It's like it's a password for your dev ID, and you can pass that password in a script, for example, when you do all the notarize things. But even if you do it through Xcode, it's not going to ask you if you I forgot how you do it with the visual Xcode, but if you can set it up so that it will use where it will use the thing that's in the keychain already. It's not going to ask you to type anything. So it's so there's ways to fix that part.
Okay, I'm setting things up. Should work, hopefully. Please note that the version I have is not 100% stable. It's still working on features. Things might crash, so beware. The version that is out right now is a public beta, and it is pretty stable. So don't be afraid to get it. It's not going to cost any less anytime ever. So
Wait,
this is
Asaf,
the lowest price it's ever going to be.
Hey, Asaf, I think your voice got lower for some reason. Right?
Shouldn't have. A.
Yeah, it's almost like
How about now?
Oh, yeah, that's better, yes. So
Okay. Let's see. Sidechain. Because I've changed the settings in the audio sharing stuff, so I can give you guys stereo action. Now I can't hear anything.
Can you share the screen?
Whoa. Can you hear it?
Yes, but we can't see it.
Yep, I know. Prepare a surprise. Window. Let's see if Logic is good with sharing the plugin window as well. Can you see the plugins?
Okay, 1 second. Wait. Here we go. I can only see Logic.
So annoying. Let's see. Stop screen sharing. I'll have to share my entire screen, huh? Let me close some stuff if that's the case. Ooh, DaVinci is open even.
Yeah, so David says
almost
that the filter was really loud compared to our voices.
That's a good thing. I'll reduce the volume a little bit. Entire screen. Let's see if everything is well tucked away. DaVinci Resolve has crashed. It's not my fault. I think. Terminal quit. Okay, I think we're good. Let me make sure. Yeah. Entire screen. Share. Okay, now you should be able to see everything.
Okay, let me bring up the... Okay, looking good. Look at this beautiful plugin.
You know what? Maybe it would be safer to do this here.
So just to give some context to people who are just joining, I'm here with Asaf Darsogol from Polyverse.
How's this? How's the sound now?
A bit louder, maybe. I don't know. Yeah, looks good. So Asaf is
I
joining.
wonder how how's the quality of the stream in the audio regard.
Here it sounds good. I don't know what you're hearing, but so first of all, I just want to say that so Asaf now is showing the new Polyverse plugin called Filterverse, which is now in public beta, right?
Yep. It is in public beta, and the reason that we like to do a public beta is mainly because I'm a musician, a professional musician, and I hate, my pet peeve is software that's being released as a final version that is in beta quality, that crashes on people during their live shows. I don't believe that we are big enough to have 1,000 beta testers in Polyverse. So this is our way to get 1,000 beta testers before version 1 release, so we can have a software that when it hits version 1, it's super, super stable.
And you know, that's something, what you're doing is something that I remember when you started to do that, I didn't see it a lot, but I do see it now quite often with games. They do this early access thing where, yeah, so it's something that gets, that people will actually pay more to be in the early access of the game sometimes and to get the beta version.
So our beta version is heavily discounted, and we're not a very discount-oriented company, so it's very rare to get discounts. We don't have a lot of sales, and if we do, they're not deep. And so right now you can get Filterverse for $79 instead of $149, and in about a month it's going to increase to $99, and after a month later it's going to be released as version 1 for $149.
Yeah. So,
yeah,
you can see the comment here. Oh, I don't know if you can see it, but I'll read it. So the comment is, "Whoa, shush! I don't know if you made it, but the design is so clean."
So maybe that's the point where I give some credit to the creators of this plugin. It's not just me; it's also my partner Aviram, which is a genius mathematician, coder, and electrical engineer. He is the real techie between us. I'm more in the artistic side, and he's just like, whatever I have in my mind, he will find a way to describe it mathematically. He's awesome. The graphical user interface was created by Scott Kane, and he's just, wow, so he's just a genius and so good at making all of this happen. Besides that, we had some help from other coders, which are now not part of Polyverse, but they've worked on it. So thank you, Stacy. And one of our coders has changed her name, and I don't remember right now. Let me see. Eurydice, thank you for helping us with this plugin. So yeah, we've had all hands on deck with this plugin, and of course, very important to remind of Erez that is maybe doesn't code directly, but is a big part of the creation process and the inception of our products. Erez is from Infected, but also from Polyverse. So for instance, here we have Swiss Army Knife, which is a state variable filter. And the nice thing about this filter specifically is that you can have a lot of resonance, but also control the balance between the original sound and the resonance by pushing a little bit more. And as you can hear, it kind of displaces the resonance. And it can go up to 12 in terms of resonance. Whenever you cross the 10, it will self-resonate. So usually I tell people, be careful, it's going to self-resonate. But as you can hear, it doesn't sound so bad when it self-resonates.
You mean self-oscillate, right?
Yeah, self-oscillates, yeah, of course.
Okay.
And I can basically balance between the oscillation and the audio itself. And it kind of warbles too when it kind of displaces it. Yeah, so it's a much more controlled resonance than most digital filters that you've heard. Some filters that are out there do have this feature, and you should use it. And a lot of people are not aware that the good filters need to be gain staged. So now you know. This one has all kinds of types of filters. You have 4-pole, 2-pole, band reject, band pass, peak. Wait, am I? Okay, no. Good. Just wanted to make sure that there's no bleed from the speakers. And high pass. So yeah, that's a Swiss Army knife, and it also has some drive. That is very different from the bread and butter, for instance. You can hear the big difference between the drives. And the filter also sounds different. Um, so each of our filters just sounds completely different. Some of them have more crazy features like extreme pole count. This is my favorite bandpass here. Those filters are very stable as well. We put in a lot of attention to make them unbreakable, so you can really modulate them drastically. So for instance, here I have an oscillator that runs in audio rate. And actually, let me just finish setting up the DAW here so they can both get MIDI. I can add an envelope. It can control the depth of the modulation. Yeah, so those filters are very detailed and high quality. But on the other spectrum, we also have some filters that are, well, less orthodox. Let's just say it like that. So this is Robocomb. It's a comb filter, and it has it's my pet robot. We also like to take things that are familiar to all of us, like a reverb. Let's and treat them as if they are filters. I love this filter for this reverb for many reasons. One of my favorite reasons here, besides it having a very, very smooth diffuse tail. So this is 0 diffuse. This is 100% diffuse, and you can hear it doesn't sound particularly. I'll add some damp here and a lot of resonance. And now I'm going to show you my favorite feature, which is the detune.
The comment here is that watching this stoned is so trippy.
Well, uh, I approve this message. Here's a lot of detune here for you.
But I think this is something that should be explained. Can you maybe explain how can a filter be a reverb?
Sure. I guess I need to go back a little bit and explain how a delay can be a filter. So, a delay has a frequency, basically. The time that the delay takes to repeat itself, it can be converted into a frequency. If you take a delay and feed it back, the repetitions can create some kind of oscillation, kind of like a resonance. And that's basically a comb filter. It sounds like this. 100% true. And so let's take this flanger, for instance, the comb filter, and I'll make the synthesizer play some white noise so we can actually hear the pitch of that, the pitch of the cutoff of the flanger. It's not really a cutoff, it's a center frequency or the fundamental frequency, but we like the romanticism of treating everything as if it's just a classic low-pass filter that has cutoff and resonance. So we use cutoff sometimes instead of the right term, which is frequency. Okay.
Yeah, because you do have like a uniform of the interface, right?
It's not just the uniformity of the interface; it's also the experience of romanticizing the filter. You know,
Okay.
so the cutoff is the knob that's the most romanticized on any synthesizer.
Okay.
And we just want to have a cutoff filter for the reverb as well. That's it. So let's put some not white noise, maybe pink noise, so people's ears will stay intact. Okay. Now I'm going to take some MIDI here and assign it an octave. And I need to okay, so I can actually play with it. It has a pitch, it has resonance, and a reverb is basically built out of many comb filters and all-pass delays, which is kind of like a feed-forward and feedback comb filter at the same time. So it's basically like two comb filters. They go like this. They interact together to make an all-pass. And so a reverb is made out of a lot of filters. Those can be moved together. And in most filters, this is the size parameter. But for us, we changed not just the range, because as you can hear, we have very small room sizes here. Sounds like a tin plate. Or a very huge space, yeah? But we also changed the curve of the control to be interpreted in hertz. And so, for instance, let me show one kind of thing here. I'm going to use the meta knob with a little bit of glide to control the pitch of the tail of the reverb by a fifth. Okay, so 7 semitones. And let's take a saw oscillator that has a pitch. Okay, good, with a lot of resonance. Now we have a tail that is a fifth up and back. So you can actually play with the tail of the reverb.
Oh yeah, your audio got quieter for some reason.
My audio got quieter. How's this? The DAW or the microphone?
No, the DAW. The DAW.
Okay.
Yeah. So wild.
So yeah, that's space, for instance. Do you want a? I have a filter that I'm still working on. Do you want a small preview?
Yes, that's
It
gonna be
might
awesome.
it might explode on us,
Ah,
but
that's
who
okay.
cares?
That's okay. You know, we've all exploded many times.
Yeah. So I'll also take. I'll also do another thing. I'll open. Will I open? I'll open a development plugin that I have here, which is a scope, so you can actually see what's happening. Um, okay, initialize. And I'm going to give it a sidechain from the synthesizer, so it's going to be much more stable. Nice. Now I have a nice oscilloscope for you guys to watch on the bottom here. And let's see what this filter does. I'm going to start with the most basic setup. Huh. Oh no.
What happened?
I have to fix some stuff.
So the
But let
comment.
me see.
So what? So one comment is this is amazing. And
So this is a
yeah.
decimator of sample rate reduction filter. But the crush functionality is not existent at the moment, so bear with me. I'm not going to recompile just for the crush functionality right now because I don't want to start coding right now. But it does have two features that I'm kind of proud of. So the first one is that let's look at okay. Let's look at the types of filters that we have here. We have a regular sample rate reduction, and you can see this is what you already know from most plugins. But we have different types of interpolations. So, for instance, we have a linear interpolation that takes those steps and just creates a straight line between them, or just has a smooth transition between the steps. Okay, this is linear, or I can go even smoother, but it still has this raspiness. But also, it also has the possibility to add resonance. And yes, it sounds very digital and nasty, which is why I really love it.
And you can also stack another filter after that to
of course, you can
mill
stack
that,
3 filters, but also you can just use, if you don't like the high end, if you want it to sound a little bit more tamed, you can change the interpolation. And another thing that you can do is you can change the way that the samples are averaged between each sample. So this is a little bit less noisy, or noisy in a different way, or even less noisy. And this is the smoothest one, right? This is the linear, and this is the smooth interpolation. And that starts to sound more like a regular filter. We have the sine interpolation. So let me show you some of those interpolations as I move along between them. But you probably seen that I started from step, right? The step interpolation here. Let's remove the... And the step interpolation is the classic one, but I have below the step interpolation are the more destructive ones. So let's start from the first one. This one will start from the second value and fade to the first one. The next one is starts from the second one and then steps to the first one, and then second, first, second, first. Then step is what you know and love. Curve is a curved step. Linear is just a straight line. Smooth is a cubic interpolation, which is what you usually are used to when you reduce the sample rate. Unless you're doing it offline, then it's a sync interpolation, but this is a real-time one. Then we have the weirder smooth ones, which is a sine interpolation, and you can see that waviness of that line, but it can go even worse because I can add not just half a sine, I can add a sine and a half between them, or 2 sines and a half, or 3. And this will actually give you the third overtone, 5th overtone, or 7th overtone in the resonance. And of course, you can modulate the interpolation as you wish. Yeah, so the crush stuff is, I just disable it for debugging stuff, so unfortunately you can't hear it today.
Still sounds so cool, in my opinion.
Thank you. Yeah, and we have many more filters. I'm not going to delve into these right now. I think it's better that you guys go ahead and download the demo from the support and give it a go, and tell me if you like it.
Yeah. Do you? I don't know if did you say when when does the final version is coming out?
Probably in about two months. When I say 2 months, probably reality is going to dictate 3, but who knows? I hope like 2 months. Right? I hope by August we will have something out, because I want to take a vacation at the end of August.
Vacations, yeah. I heard about that.
Yeah, I want to go. I want to go see some national parks in the United States.
Do you have a specific one that you're eyeing?
Yes, I do. I have actually 3. I have Olympic National Park, and North Cascades, and Mount Rainier.
Olympic National Park.
That's all around Seattle.
Okay, awesome.
And
it's a great area.
It's just beautiful out there, especially in the summer. It's not too warm, and they have lots of streams, and everything is green. It's beautiful.
Amazing. Yeah, well, let's see what's up in the chat here. Look at this comment from David.
Sorry, David. I really went easy on you guys and did not do the regular demo spiel Um, if you want to see the demo spiel, go to our YouTube channel and check it out. And of course, just download the demo, listen to presets, see if it suits your workflow.
Yeah. Do you see the comments on the screen, or do you
Yeah.
still see your? Oh, okay. So
Thank you,
yeah.
David.
Yeah. So it's yeah. So I think it's quite an amazing plugin. Like I told before in the stream, Supermodel is something that I'm always using in a mix. It just became this thing that, like I always just, it's just.
It's
one of the
worth
best
mentioning
sounding
that you are part of the reason that this product exists, really.
Me? How am I
Yeah.
related to this?
We had a meeting about 6 years ago in a flat in my hotel room in Israel when I came to visit.
Okay.
And you were complaining about low-pass filters for
Yes.
the bass.
And that's exactly what I'm using it for.
Yeah. And I told you, what are you talking about? There's great filters. And then we started looking for filter plugins, and we didn't find anything that we said, okay, this is decent. Since then, the drop was released, and I think it's great.
Mm-hmm.
But I think it's great for a very certain type of filter, and I like the more sci-fi end of the spectrum, which it doesn't. It's more of a analog modeling type of filter, where what I like is more the digital, nasty, crazy robotics, and yeah, stuff to make IDM with.
So interesting, because like you say, when we're there's a lot of really good filters in synthesizer plugins, but there's almost no filters that are meant to be musical filters and that are like standalone, and they have stuff like modulations, like the stuff that you've added. They're like kind of synth filters, but with an external source. Really, like it's
Yeah,
it's
a lot of
pretty unique.
synthesizers can be a filter as well. But I think we definitely, once the beta is out, it's going to be more apparent because we're saving some of the heavy hitters for the release. But we are definitely taking the filter flag and moving it forward by a couple of miles. And hopefully somebody will take that flag and move it even forward after us. But yeah, this filter is going to allow some stuff that's never been possible before.
That's
Kind
so
of
cool.
like what Modalics is doing with music theory and basically understanding of rhythms, understanding of idiomatics of an instrument that you guys are masters of. And I don't know if people here know, but Modalics didn't start when Modalics started. Modalics was already a thing with several products that in waves. You guys worked in waves and created the bass
Yes.
plugins that basically did kind of like what Mindset for drums does now. Mindset is deeper and more elaborate even. But the idea of taking an instrument's idiomatics, and that means how does an instrument work? What kind of phrases are you allowed, or is it easy to play? How does it sound? How does it transition between two note sound? How does what happens if you hit a crash several times? Does it sound again like you're retriggering the same sample over and over again, or is there some kind of things that evolve? What happens if you have a ghost note on the one or on the and of the bar? Does it sound different? If a snare is being hit after a ghost note, or a ghost note is being hit after a snare, does it sound different? Are there combinations of drums that create some kind of synergy? And all of these things are something that you kind of are cracking the code, and that I consider that taking the flag and moving it several miles ahead in terms of making the code of music. You're helping to crack the code of music and putting it in the hands of musicians. So Modalics is awesome, and I'm really waiting for that moment where it would be very obvious when people say Modalics, they'll understand what you guys are doing. But I think it's not close yet because the depth of your niche is just starting to be carved by you guys, and this is a rabbit hole, really. And you're the only people who are doing it, and it's basically you're pioneers in that regard. And when people, it's the hardest thing is to do when you're pioneering a field, is to explain it to other people. What does the field mean? What does it say? And so on. But I believe that in a couple of years from now, when people say Modalics, it will be synonymous with cracking the musical code, and that's the future that I envision.
Thank you, Asaf. That means so much. I really need to get you to. I have I have good quotes from you now. I'm actually going to. I'll make a short.
Use it. Or something. You can use it. Put it on your website.
That's amazing.
But I want an affiliate link.
Yes, of course. Man, I'm so happy you could just jump on the stream.
Yeah, me too. Thank you for having me.
That's awesome. I think I've been streaming for like almost 3 hours now, so I think.
Oh wow, yeah. And I have to get back to coding. You know what I've been doing.
Yes,
so,
me too. But I probably need a break first. But maybe I'll run another stream later after I eat something and kind of.
Awesome.
Man, thank you so much. I'm so happy we get to this. Maybe we'll get you here again soon, and you can even show more. It'll be good if you can, do stuff like reviewing like the stuff like Supermodel and Manipulator.
I think it would be cool.
Comet.
I think it would be cool if we could make a live stream on the Modalics website and try and combine both our plugins.
Oh, for sure.
And make a project that is just made of Polyverse and Modalics music, and maybe there's going to be some material to be cut for shorts after that. Let's see.
Yeah, because the Eon synthesizer, the built-in synthesizer, Eon ARP is our arpeggiator plugin. That synth is pretty rudimentary, but if you put a good filter on it, it might be interesting.
That's true.
And same with Beat Scholar, right? So even if even the built-in sounds from Beat Scholar, if you pass them through.
Wow, I have really nice presets for drums with the Filterverse and Supermodel. I think Beat Scholar with those.
And you know what we could also do? Because
Beat Scholar can actually sequence the filter.
That's what I was gonna say. It can do we can pass it in sidechain, and we can put different tracks of Beat Scholar that are used for sidechain, that are just used for this, and then we can kind of do it. Let's do that.
It can even control it. It's control the filter by MIDI.
It can do MIDI, yeah.
And the filter can actually synthesize drums.
Yeah, so we can either do envelope detection from the
Beat Scholar with I Wish would be insane for sure. There needs to be like a Beat Scholar that one of the channels is this possible with Beat Scholar to just have one? Can it send MIDI and audio at the same time?
Yeah,
it does that, right?
Yeah.
So and
multi-track as well. So we can have multi-track out. I need to see because I think like it depends on the DAW, but I think, for example, in Cubase we can take input from a specific audio output and then route that into the sidechain of.
We can also use assign a drum for glitching with I Wish. So you will have like a snare, bass drum, and a glitch color.
Yep. We can do that. So I think we can actually make quite an awesome project.
Yeah, I just wonder what would be the best way to kind of interfere together on the same DAW, DAW.
What do you mean? What do you mean interfere?
Like maybe we'll run the DAW on your computer or mine.
Oh, you mean how are you and I going to?
And then we can make the same project together live. Or can we synchronize two DAWs?
That's going to be difficult because you're processing. No, but we can do one. We can do The only
Yeah,
thing
with
is,
some
if
screen controlling, like mouse sharing or whatever.
yeah, yeah. I mean, I can give you, like, if you do it through my computer or whatever, I can give you an AnyDesk or something, and you could just remote control. You'll get a bit
Yeah,
of
let's make
latency,
some remote
right?
control music.
I love this. I love this. This is going to be awesome. Okay, so we can let's make a plan now that we're going to do. Let's do this like next week or something, and this is going to be
Yeah,
pretty awesome.
cool, cool, awesome.
Awesome.
All right,
All
thank
right.
you for having me.
Thank you. Bye,
Bye.
everyone.